Good morning, good afternoon, and good evening, wherever you're joining us around the world. Thank you for joining us for the Harness the Power of IoT presented by Progress in Kings Lake. Today's agenda, we're going to cover a few things. One, our intro, a little bit about Progress Rollbase, our low-code application development platform, the Kings Lake case study, which we're all here to hear about, our QA session, and we'll be happy to wrap up. Today's presenters are myself, Adam Day. I'm the Director of Product Marketing here at Progress for the Rollbase platform. And I have joining me from Sri Lanka, our Kings Lake partner, Dr. Dharma Basan, who we refer to as Dr. Dharma here. And Dr. Dharma is the chairman and founder of Kings Lake, a Progress partner since 1996. He's grown Kings Lake to provide mission-critical applications to a large number of manufacturing, distribution, and logistics companies in Asia. Prior to founding Kings Lake, Dr. Dharma has taught applied mathematics at University College London and carried out research focused on non-destructive evaluation techniques for offshore structures. This led to the development of tools for real-time software and specialized electromagnetic sensors. He has a BS in civil engineering and a PhD in mechanical engineering from the University of College London. Welcome, Dr. Dharma. So let's spend a few minutes on Progress Rollbase and some of the market forces that bring us together this afternoon. As we know, as we are faced with developing applications in this environment, there are market forces that press upon us at an ever-changing rate. Data is exploding and coming at us from different various touch points, proliferation of mobile and connected devices. We're used to seeing everything feed me data and be able to act upon that data as we move forward. Yet our time to market needs are shrinking because we're expecting these revolutions and iterations to occur at a much faster rate. While these multi-channel evolutions are occurring, we're seeing these devices from anything from a wearable, PDAs, traditionally old-style laptops, but all types of form factors and such. Just looking at the last 5 years of wearables will be doubled by the time we get to 2020. So the escalation, as we see, is a difficult process to keep up. But now we have all these wearable devices and connection points around the world, and from dog collars to airlines to TVs and microwaves, and be it escalators and staircases inside our homes, we're now sharing that data and trying to act upon it. While this is all excellent data to house, what we really want in the end is to make intelligent applications. Intelligent applications now act upon this data that we've aggregated into various pools, and now we either need to make deterministic determinations on it or predictive decisions based upon that data, thus making the applications think. Now, while all of this is occurring, we actually don't get any reprieve from having this giving us longer time frames to market. We're actually requested to make this easy to create, easy to change, and faster to market without any trade-offs in reliability or complexity. Thus, it brings us to Progress's mission: to provide the best technologies to build and deliver mission-critical business applications. And we do this through a various set of products, both focused at developers and business users alike. The one we'll be focusing on today is Rollbase, our low-code application development platform. And a low-code development platform is one that enables fast application development delivery with a minimum of hand coding. It accelerates and allows us to focus on the core components of our application and solution versus the mundane, repetitive functions. So let's take a look at what we can do with Progress Rollbase. We can build an application as fast as you can define the requirements. Applications are built off of defining a data model and in the background creating the screens and application architecture immediately through a drag and drop model. Integration to these data points and IoT devices is always limited or restricted by the availability of integration points, and we've solved that solution by creating dynamically our REST and SOAP integrations as you define your data model, available to you immediately accessible to external parties. Not only that, we're also a real-time engine, so as we build and deploy applications, the time-consuming process of deploying and iteration is accelerated by the ability, once you make a save to a platform item in the application, it is immediately available to use and see and thus inspect. The last step is we can also build prototype functions in a matter of days or weeks. There's a lot of ideas that sit in our heads in business departments, IT and the like, that never get to come to fruition because of resource limitations, Progress Rollbase and low-code application platforms provide that tool set to bring many of these ideas from concept to life in a very short period of time. So let's take a look at how we accomplish this with Rollbase. First, we generate our application by building a data model. Being a runtime environment, the platform handles all of the back-end work for creating the data model and creating the screens that we use to interact with the application. The next step is to customize the application by integrating our business logic, enhancing the user interface, building integrations to third-party applications. And if we like what we see, because it's a runtime environment, I'm able to see and save each of these changes and see them in a real-time effect. If I like what I see, I then can push deployment to my users. Unlike traditional development where we have to compile and deploy, being a runtime environment, it allows us to iterate at a much faster rate, essentially putting us into a continuous testing. Now, based upon the savings in time and effort, depending upon the complexity of the application, we have seen a reduction in development efforts ranging from 60 to 80%, allowing you to accelerate the mundane, repetitive core items of a platform and being able to allow yourself to focus on the development of the business application, which is really the core to generate revenue and internal efficiency, which we believe makes Rollbase the fastest and easiest low-code platform to build, deploy, and manage enterprise-class business applications. And with that, I'd like to turn the presentation over to Dr. Dharma and Kingslake. Doctor?
Thank you, Adam. Good day, everybody, wherever you are. We at Kingslake have been working with manufacturers in Sri Lanka for the past 20 years, mainly helping them improve efficiency and productivity. In the early days, it was primarily about internal operational efficiency. This meant implementing ERP systems built on OpenEdge. As time went on, we have extended this to a number of other areas within the factory to measure, monitor, and optimize production. Again, built on OpenEdge. These are all on-prem applications. As far as manufacturing goes, Sri Lanka has two major exports. The first is Ceylon tea, a traditional product that still carries the old name for Sri Lanka, Ceylon. The second started in the mid-80s. It's now a $5 billion industry, mainly apparel, primarily for mid-tier brands and in particular what are known as technical garments. The industry is dominated by two very large groups who are more than contract manufacturers. They do everything from R&D to design and manufacture for a number of large brands. These two together have around 120,000 employees in Sri Lanka, with factories in other parts of Asia, Africa, and Latin America. The third is owned by a large Italian group that has its own three brands. They have around 3,000 to 4,000 outlets around the world. Typically, the factories are spread around the country. The reason for this is that they need a catchment area for workers, as each factory has anything from 2,000 to 5,000 employees. Sri Lanka, like many other developing or mid-income countries, has issues with infrastructure, public transport, and so on. As a result, many factories provide transport to their workers from and to their homes. The application that I will present to you today handles the whole process of factory transport and builds on the use of data collected from sensors. The system you will see is built with Progress Rollbase over the past year and is now managing around 15,000 workers, with trials being done by other factories and, interestingly, by an international bank which has its call center in Sri Lanka. As I mentioned before, we have been working with manufacturers looking at improving efficiency and productivity over the past 20 years. A number of these developments were done by building systems around traditional systems of record. About 18 months ago, we started looking at the process of worker transportation. So the problem we need to solve was, how do you provide transport for thousands of employees? So when we looked at the needs, we found that for the person or department handling the organization transport, there will be literally thousands of requests generated on a daily basis. The reason is that there are different types of requests. There could be routine requests, which would be the normal program during the day. There might be a need to do overtime and shifts. And this means that the routine plan would need to be changed dynamically based on daily factory requirements. In addition, during the course of the day, there will be a number of ad hoc requests for travel to other factories or suppliers to inspect parts of manufacturing, clarifications, and so on. Finally, it was about the money. A 5,000-person factory needs about 100 buses just for routine transport. Add to this all the other trips. Pooling was difficult. If a few people need to go to the same area, there might be several vans or cars going. As a result, the costs were high, and also there was no real visibility of the actual number of kilometers traveled. So at the end of the month, there was an issue about the billing. So based on this understanding, the functionality of the system we developed covers 3 areas. The first is planning. This is where we manage the who, the what, how, and when. So the employees, the drivers, the vehicles, the destinations. It's during this stage that all the requests are managed and matched with trip itineraries. The second part is the tracking. So during the tracking stage, all itinerary information is loaded to devices in the vehicles so that onboarding and offloading of passengers, the location of the vehicle, and any other particular events can be tracked. The final part is the monitoring and control. During this stage, we not only monitor the actual usage, but also provide metrics on the efficiency of the transport application. So you could see trip histories with actual routes. You can see exactly what the vehicle capacity utilization was, and so on. So now let's look at an animation of this whole process. So the whole process starts with the transport request coming in. These could be routine or regular, shift or overtime work, or there could be ad hoc requests. So this is the department that does the planning of the transport. So based on the requests coming in, itineraries are produced, taking into account constraints. The constraints can be things such as maximum number of passengers per vehicle and the maximum duration of the trip. So for example, you could optimize if you decided to have 100 people in one bus, the cost would be minimal, but the time it takes to drop all these passengers would be too long. So therefore, there is a constraint in terms of maximum duration for the trip as well. The route is also optimized. This data is then loaded to each vehicle. As the workers board the bus, they would tap an NFC card when they get in. This allows various checks to be carried out, such as, is this the right person in the right bus? Remember, there are 5,000 workers, so it's about 100 buses, 100 to 120 buses in the evening, and so you do need to make sure the right people are in the right bus. Once all passengers are boarded, the driver knows that everyone who should be there is there. Then the transport takes place. The system monitors the route being taken, where the passengers were dropped off, and most importantly, from a safety perspective, the system records the drop-off time and location. So that gives you security as far as the employee is concerned. And finally, the system records what happened during the monitoring phase. Passengers waiting on board can be notified by SMS when the bus would be arriving. In addition, if there are breakdowns or accidents, the center knows about it and replacement vehicles can be sent quickly. Also, the data can be analyzed and reported on for further improvements in quality of service. So the solution is end-to-end transportation. So it is essentially a traditional transport management system is what you have in one part. The second part is GPS tracking with mobile devices. The GPS tracking part has been around for some time, but in the past required specialist equipment and the cost was too high. Now, with mobile devices, it is feasible to put this into all the vehicles that a factory might use. And this is the bit that allows us to add a lot more value. We partnered with Dialog, the leading telco in Sri Lanka, and they provide the data connectivity, the infrastructure, and the NFC cards and devices. Essentially, these cards can be used as ID cards to be stored value carriers as well. For example, they can be used to pay for meals at the canteen or bus tickets. So Dialog has this whole infrastructure, and these cards are used for multiple purposes. Each employee has one of these cards, and this is used to enter and leave the vehicle. The card can also be used for a number of other employee benefits with the company too. You might ask, why not just an NFC-enabled smartphone? The issue is cost. In many parts of the world, the classic mobile phone is still in use, and SMSs is still the main means of messaging. However, in markets where NFC-enabled smartphones can be used, the same system would work. And finally, from a factory perspective, this is an important application, but not core to their business such as the ERP system. Therefore, the availability of a cloud-based solution is attractive. Not only is there a saving in terms of costs as far as servers and so on, the business model is pay-per-use and is billed by number of employees. This makes economics much simpler for the factory as the cost is added to each employee. The next few slides, I will show you what the application looks like. I will take you through the different workflows. Here, we have the dashboard that the factory management or the department managing the transport process can view. In this case, there is only one vehicle over there. It shows a map with all the vehicles being tracked and the number of employees in each vehicle. This is a real-time view, and each vehicle transmits data every 4 seconds to the center. The next few slides show how we manage the information about each employee. Here we see a forms-based screen where employee data can be entered or edited. It is also possible to enter address information by picking this off a map. Finally, there's a self-service portal where the employee or guest can enter information directly into the system. All this is standard Rollbase, and with the latest release works very well on multiple devices, from web to tablet to phone form factors. This one shows how we maintain all the destinations that are in the system. So again, you have a map view and the specific addresses. This slide shows you the standard routes that are already in the system. It shows duration and the route. Now we have the driver and vehicle information, and on a daily basis, we can make sure how this can be mapped to the itineraries. So we have these itineraries here, and this is a routine trip. The system allows the user to plan for trips for a given period at a given time. And you can see in the right-hand side the days that you want to run this routine. It automatically brings all the employees attached to the selected routes, and you only need to plan this once. Throughout the period, each day, the system automatically generates the trip which gets loaded onto the mobile device for tracking. And here we see all the requests that are pending for the day. The next slide shows how a daily request can be added. So this could be an employee, or it could be a guest, essentially asking that they go from place A to place B. And finally, here we have the whole approval process for all the requests before the final planning takes place. Now we look at the planning process. The quick planner is a good solution when you have properly defined zones. So essentially you have zones, subzones around the factory. It brings all the requests from the same zones and subzones together so that the planner can plan one vehicle for multiple requests. However, there are situations where more control is required from a planning perspective. This is where the visual planner comes in. You can mark out the area and select the order of the route. So this is where you define a zone. And at the end, the system does a check based on predefined rules such as duration of trip and maximum number of passengers in the vehicle. So you can see here, there are some error messages coming up saying that you have exceeded the number of employees for a particular vehicle, and the estimated duration is more than 60 minutes. Remember, we said that we put constraints in terms of number of passengers per vehicle as well as the duration for a trip. This is where JavaScript is used with Rollbase to check the rules. In the future, we are doing some trials with Progress Corticon business rules to see if this could be a more flexible way to add this feature. And here, we have a label provided so that the buses can have these so that workers know which bus to get into. As you can see, we're using the multilingual capabilities of Rollbase to print out the labels in Singular, which is a completely different script. Each vehicle has a mobile device that collects data and transmits data in both directions. The mobile device also stores data locally in case there is no data connectivity and synchronizes data as soon as data connection is restored. We recommend that a rugged mobile device is used, since a device has to be used in buses and multiple people have to tap onto the same device. Also, as we all know, the battery life of the device is important, since GPS tracking drains the battery much faster than normal use. So the mobile device allows the driver to start, pause, and end a trip. In addition, they also have visibility of the route, passengers on board, and so on. Also, in case of accidents, breakdowns, or other non-planned events, the device can be used to send notifications to all the stakeholders. At the moment, we are implementing a geofencing mechanism so that we can send automated notifications to the employees before the bus reaches their destination. The mobile app is a native application written for the Android platform and is integrated with Rollbase. So, the trip is now over, and this slide shows what happened after the trip. It has actual data. We can also replay the trip. So here you see what actually happened, and in this case all the GPS data has been collected properly, and we can replay exactly what went on. There are situations where sometimes for parts of the journey GPS data could not be collected for whatever reason, and then it's highlighted slightly differently. So this is the whole system in a nutshell. As you can see, it does everything from planning, tracking, to monitoring and control. In the next few slides, I would like to share the benefits that all the stakeholders were able to get from the use of the system. Some expected and some unexpected, that were much more valuable in the end. We have categorized the benefits into safety and visibility, return on investment, and operational efficiency. So in terms of safety and visibility, the fact that you can see where and when an employee got on the vehicle and where and when they were dropped off is critical. A number of workers are women, and this is important, especially when the drop-off is late in the evening. Again, on the theme of safety and visibility, there is full visibility of capacity utilization of the vehicles. There is complete visibility of the route, the journey time, how many people were in the bus, and so on. And all this data is available for review later on. So now let's look at ROI. The planners now take a lot less time to organize the vehicles. In addition, before the implementation of the system, decisions about overtime had to be taken by 1 p.m. Now, the cutoff time is 4 p.m. So that gives an extra 3 hours to decide whether they're going to run overtime or not. There are also savings in terms of optimal routes and consolidation of transport requests. This means that a lesser number of vehicles are used, which at the end of the day reduces the total cost of operation. The third area is operational efficiency. The obvious benefits are through better coordination with suppliers, as well as the advanced notifications via email or SMS. This means that passengers do not need to unnecessarily spend time waiting for the bus. However, a major benefit that came about was the advanced notification to the factory before the workers actually arrived at the factory. A typical 5,000-person factory has an absenteeism around 5%. This means that on any one day, 250 workers are absent, and some of them have special skills. In the past, the factory would only know who was available after the workers arrived at the factory. Then what happened was a quick scramble by the planners to reallocate work, move people around, and so on. This could take anything up to 1 hour. Now, with the advanced notification, they are able to do the planning before the workers arrive. This has a major impact on the efficiency and productivity of the factory. This was something that we were not really fully aware of till we implemented the system. And in fact, the benefit of this is major compared to all the other savings that they have got out of the system. And what we are also looking at now is, again, seeing if the line balancing can be done automatically, because we have the information on who the workers are at the factory. We know what their skills are from the HR system, and we do have the planning information as well because we access the ERP system. So the next phase could be automated line balancing system. If you were to do this, that's a significant benefit financially. So here we have the benefits summarized all on one slide. Safety and visibility, ROI, and operational efficiency. Just give you a few seconds to read through that. Now I will move on to the architecture of the solution. So we start with the devices. Here we are using NFC cards, but there is nothing to stop the use of RFID tags or other identification means such as cameras. The data is collected and transmitted via mobile devices to Rollbase, which holds all the business logic and transaction data. And using Rollbase's responsive capability, we are also able to handle multiple device form factors. At present, we have used native development on the mobile devices. It's standard Android. However, moving forwards, we're using native script, as this has much more flexibility to access the underlying hardware of multiple device platforms. Now looking at the architecture itself, the first use case that we are looking at is workforce transportation. And this uses a mobile application which has GPS tracking, NFC, and then we use data syncing to get the data into Rollbase. There are two other use cases where we are doing some trials at the moment. The first one is cargo transportation. Here, we're also connecting to other sensors such as temperature, humidity, and so on. The third use case is tour group transportation. In this case, it would be difficult to force guests to tap NFC cards, and therefore an RFID type tag would work better. And here, it would be things like Bluetooth beacons and so on. The other bit of the puzzle that that's currently being worked on is to see how we could use Progress Cordicom business rules to build different rules to help with route planning. Because at the end of the day, there are a large number of rules that are used to decide on the routes. So this would make it a lot more flexible, we believe. So now that the system has been in operation at a couple of sites for a year, we can evaluate the value to the various stakeholders. Firstly, the main value to the customer, which is the manufacturing plant, is the advance notification of who is going to turn up for work. This is a significant benefit and can be quantified in dollar terms. In addition to this, the enhanced safety and optimal use of resources gives added benefit. Obviously, these factories are incredibly conscious of reputation, so the safety of the person coming into work and going back home safely is important to them. For a 5,000 person factory, the annual savings is around 100K after paying for the system. And don't forget, this is in countries where wage levels are quite low and so on. So it is significant. By US standards, it might look low, but when you look at it from the perspective of developing or mid-income countries, this is significant. The system also has advantages for the transport contractor. Although they were initially skeptical and in some cases hostile to using the system, partly because they thought that their customer was going to spy on them and make sure that they were going to reduce the amount of money that they paid and so on. But once they have started using the system, they're finding that the perennial billing disputes are no longer there, so they get their money much quicker, and the additional visibility also helps them and their staff. And in fact, a couple of the transport contractors are now talking to us about implementing the system and using it as a sales tool to get additional business. And finally, the value to the employee. The employees too have been positive about the system, as with advanced notifications, they no longer have to get to the bus stop too far in advance. In addition, the contribution to personal safety is a big plus. And at the end of the day, their bonuses in terms of meeting efficiency KPIs and so on is helped as well, because now the factory does the planning a little bit better. They're able to produce a little bit more, and so they in turn benefit from additional bonuses. And before we conclude, we would also like to comment on the value to Kings Lake and Progress, because we've only talked about the customer, the transport contractor, and the employee. For us, this is Kings Lake, by being able to develop the system such as this rapidly, not only gives us more opportunities to retain our customers by being part of the newer generation of apps, but also helps us to go after new customers. So, for example, in the past, we would have had customers who were on a Progress or OpenEdge ERP system, but one of the potential customers for this runs SAP. So we are after newer customers with newer platforms, and this gives us an inroad into selling enterprise class applications to a completely new set of customers. We're also currently carrying out trials with 2 large manufacturing organizations and also with the bank, which has its call center. So this is going beyond the traditional manufacturing customers. And for Progress, we are able to demonstrate to customers that tools such as Rollbase are pushing the boundaries of app development. As Adam said earlier, it makes it a lot quicker to develop. For example, this development was 60% faster with Rollbase compared to other traditional tools. The core application was built pretty fast using Rollbase. But that saving in time allowed us to put much more input into, or effort into, map integration and device programming. This resulted in an extremely feature-rich application compared to our competitors. This is all while consuming a less effort than traditional development where we started from scratch. So from that point of view, our team is extremely happy, and whenever we present this to our customers, they too see the benefit of this. So there are quite a lot of other things that could come out of this. So to conclude, TranSmart makes use of Rollbase and IoT to provide improvements in safety, real-time visibility, and increased operational efficiency. And at the end of the day, it's also about the money. There's an 8% saving in terms of transport costs. Thank you, ladies and gentlemen.
All right. Well, thank you very much, Dr. Dharma and Adam, for presenting today. You have to forgive my voice. I'm a little under the weather. So we did have some questions that came in while you were presenting, but I do want to start with one question. You'd mentioned that it was pretty quick to learn Rollbase. Once you got started, did you have anything that you were anticipating or not anticipating that came up while you were building the app that was unexpected, or how was your experience using it?
We started about 18 months ago. So at that time, the UI was a little bit more primitive. And so that's where we tried to customize a little bit. But now with the newer stuff, it's very much easier.
Okay. So we did have one question that came in about data limits, trigger limits, and API calls. So it was kind of all wrapped into one. And it's, have you had any issues with data limits, trigger limits, or API call limits using Rollbase?
At the moment, not. For example, with the GPS data being transmitted back, one single vehicle transmits, we transmit back every 4 seconds. And if you imagine there are 100 odd buses per factory. So far, it seems to be working okay. But that is because the device actually does the data syncing part.
Great. There's one question about single sign-on that came in. I don't know if that's something that you utilize, like a single sign-on application or format to access the portal.
In this case, we don't, because it's one app.
Okay.
We'd be happy to speak to the capability of Rollbase.
Yeah, sure.
In a prior life, I actually had a company that was built on Rollbase and sold it. We did extensive single sign-on work between multiple platforms. Currently, the platform itself supports SAML, and we are working with other integration points, but we've also done single sign-on via REST and SOAP APIs. If you're in a hosted environment or a private cloud, you can actually connect via SOAP at the Java level as well. But REST, SAML, and OAuth are key integration points for single sign-on.
Okay. So I'm going to ask one because I thought the presentation was great. What made you choose Rollbase?
Well, we were with Progress. We had Open Edge.
Yep.
And when Rollbase came along, when Damien, who's here at the moment, tried it out, he was extremely enthusiastic. He is more than an Open Edge guy. He's a .NET guy as well. And when he started looking at it, he thought it had tremendous potential.
I don't see any other questions that have come up for the Q&A. So I do want to just wrap up by saying we will be putting this presentation on the Progress website in the next few days. If anyone has any additional questions, Adam and Dharma's contact information is here. But I'd like to thank you all for joining us today.
Thank you.
Thank you.